Okay, so these are the notes that go along with the flame test experiment that we did, which tends to be a favorite. So which element appears to be responsible for flame colors? So using evidence, well, how do we know which one is responsible for the flame colors? So generally, the metal atom causes the flame color. So we saw examples that copper sulfate, solid copper, the copper wire, and copper nitrate all gave a green flame. A green flame. Because Cu atoms are the only ones in common, it must be responsible for the flame. Color. Okay. And this is true for all the other ones. All the potassium was like a nice purple. The sodium were orange. The strontium were red. And the question was, would all elements produce a color? No, nonmetals do not. Okay. So, what is a flame test? It is a test used in the laboratory to detect the presence of certain metal atoms. A sample is heated in a flame, and the resulting color is recorded. Okay, so that's what a flame test is. And going back, what evidence is there that CuNO3, CuCl2, and CuSO4 all contain Cu atoms? Well, all of those solutions would burn green in the flame test. Okay, so if we want to detect if a metal atom is present in a sample, we can use the flame test. Now, how does this actually work? Well, what we find, and this is going to be our introductions to the way electrons are oriented around the nucleus, right? Because we remember that the nucleus contains protons and neutrons, and that the electrons are whipping around outside. So we find that electrons are contained in energy levels. You're going to learn about the different models, but here we have what's classically described as the solar system model, where all these electrons are in energy levels. And I would like you to draw this in. So take your time, pause it if you'd like, because I think drawing really helps you hammer home the understanding. So these are electrons in distinct energy levels around the nucleus. So when you put a sodium atom into a flame, well, this valence electron on the third energy level gets excited. It's like, oh, this is heat, and it can jump from the third energy level to the fourth energy level. And it absorbs that energy, and it jumps. It goes right out to the fourth energy level. But then, as soon as it doesn't feel that energy any longer, the electron drops back down, and when it drops back down, it releases light. So the light that it releases is always the same wavelength. So basically, the flame test worked because the atoms absorb energy and the electrons jump from one energy level to the next, and when they relax, they release energy. So what evidence is there that certain atoms are present in a compound was the question we studied. So many metal atoms produce a characteristic colored flame when compounds containing those atoms are heated, and they serve as evidence that elements and compounds are a collection of atoms.